Hello, and in today's video, we'll be going over my rolling suitcase problem by Palczynski. For this problem statement, a traveler is pulling a suitcase in motion with a total mass of m equals 25 kilograms across a level airport tarmac. The suitcase's wheels roll without slipping. The traveler pulls the suitcase using a retractable handle at an angle of 30 degrees up from the horizontal. Once the traveler releases the handle, the suitcase slows down due to rolling friction between the wheels and the tarmac, with a coefficient of rolling friction of mu equals 0.01. In this problem statement, we'll find the normal force acting on the wheels after the traveler releases the handle and the deceleration of the suitcase AX due to static friction or the rolling resistance. Some givens and assumes for this problem is that total mass of the suitcase is 25 kilograms. The angle of the handle is 30 degrees above horizontal. Rolling static friction is given as 0.01. Gravity is acting on the system with 9.81 meters per second squared. Since in the statement the traveler releases the handle, Fp will equal to 0 newtons. G is the center of mass at height h. The suitcase rolls without slipping. The suitcase has 4 wheels. The normal force is evenly distributed across 4 wheels. Air resistance is negligible. The suitcase can balance when the traveler releases the suitcase, and the weight of the wheels is negligible. Some of the formulas that we'll be using is Newton's second law, which states that the sum of Fy of the force by a diagram and the sum of Fy of the inertia diagram equal each other, and so does the x-axis. And the force of static friction can be solved with F equals to mu times normal force. And to solve for the deceleration, we take F equals ma and solve for a. So for the solution, we can go over both the force body diagram and the inertia diagram, where we see that in the force body diagram that normal force is being applied upwards towards the wheels, and that we are assuming that the force of static friction is pointing left at the wheels, and that the weight force is being applied downwards from the center of gravity G, and that the F of the force of pull is being pulled from a 30-degree angle above the horizontal, and that since the traveler was moving to the right, x of t would be pointing right. But then we can see that in the inertia diagram, because of our assumption that the force of static friction is to the left, max would be pointing to the left. Now towards applying our formulas, we can solve for the weight by taking the mass and gravity, which would leave us with 245.25 newtons, and the force of the pull would be Fp times cosine 30 plus sine 30. And when applying both F of y for the inertia diagram and the force by diagram, we can get that n plus Fp sine 30 equals W. But since we know that the traveler let goes at that instant, that F of P would equal to 0 newtons, so that we get the normal force equals the weight, which would be N equals 245.25 newtons. And to distribute that evenly amongst 4 wheels would give us the normal force per wheel is 61.31 newtons. And to solve now for the deceleration, we solve for the force of friction, which gives us 2.4525 newtons. And to solve for each of the diagrams, we can say that F of x in the inertia diagram equals max, and the sum of the forces in the x for the force by diagram is negative fr. So for the force of the static friction or the rolling. And when solving for AX, we get that the deceleration towards the left is 0.0981 meters per second squared.